Good evening, everyone, online and on-site. Welcome to our Insight online webinar, also joined with Hamilton Azure User Group, as well as Christchurch User Group, Azure User Group. So on behalf of all the Meetup group hosts, welcome to this community meetup session tonight. Yeah, please let me know if you cannot hear the sound, or if you got any video lags. I will wait for another 3 minutes. We will start sharply at 5:03. So just let me know. Pop in your chat box if you cannot see or cannot hear my voice. Otherwise, we'll start sharply at 5:03. Just want to quickly check, can everyone see the full screen? Right, just 1 second. Seems like screen. So here we go. I think now everyone should be able to see the screen. Awesome. Okay, so next, grab a coffee and we're getting started. I don't know how many people online or viewing today. Sorry. I don't know how many of you basically used fully infrastructure as a code using Azure ARM template before, but definitely ARM template is the origin of this project, Bicep. But definitely Microsoft is promoting Project Bicep as the next generation of ARM template as their native infrastructure as code platform. And today, we will look at what the actual Project Bicep is. So at the agenda, overall, we will look at what is Project Bicep, where it comes from, and what is the use case of Project Bicep. Usually we'll just call it Bicep. and its relationship with the current ARM template and Azure Resource Manager platform. Then we'll look at definitely the most important thing is the development workflow of Azure Bicep. How do we using the Visual Studio Code and all the language servers to create our infrastructure as code artifacts. And also, as well as if you are already adopt ARM templates as your preferred infrastructure as code platform, how could we migrate your existing artifacts into the Bicep platform? This is, I think, will be very, very helpful and useful and also valuable for most of the organizations that already had a considerable size of ARM templates, artifacts, and the repository, having the capability from Microsoft natively to migrate existing assets into the new platform will be very crucial in the future. And last, we will have a quick look at how do we integration all the workflows into the DevOps pipelines, excuse me. All right, so when we start talking about Azure Bicep, we cannot avoid Azure Resource Manager, which is basically the root of everything. So Microsoft has been developing this Azure Resource Manager, we call it ARM platform, as Azure's native infrastructure as a code platform for years, since the very beginning of the ARM being introduced. Beforehand is basically we call it classic resources, which is a isolated environment, different. But nowadays, most of the people from Azure Portal or use Azure CLI or PowerShell, if you even you use the PowerShell to create, for example, create any resources behind the scene, it's basically calling the ARM template. So Azure Resource Manager endpoint to create your resources, and also from the Microsoft Azure SDKs as well as the native REST API calls. So because the ARM template, so ARM, we call it Azure Resource Manager, is a REST API-based environment. JSON format file is basically a native machine-friendly, not human-friendly template that can be through into the REST API as a payload to be able to create all of your resources. So that makes sense for Microsoft at the very beginning to introduce ARM templates using a JSON format instead of any decorative language or basically a new language to be able to create your infrastructure as code artifacts. So that fully makes sense. So the people start using that for a lot of things, basically everything. But soon, all these people start realize using a Azure ARM template basically makes everyone run into horrible formatting game of Azure ARM templates. This is one of the ARM templates I wrote before for one of our customers. It has about 1,000 lines of the code. If you can see here, troubleshooting a JSON, which is machine-friendly but not human-friendly, is horrible. Even think about a few years ago, there's no such thing called ARM language server. So even before that, no Visual Studio Code, we don't have any language parser, no IntelliSense, nothing, only the native JSON interpreter that can help you to identify whether your format is okay or not. A missing bracket will cost you, usually like this, will cost you half day to troubleshoot the entire infrastructure, your entire artifact. This is a very bad, I would say, language format for developers to create their Azure environment. especially for a real production environment. Too bad. So I have been sick of it. So everybody says ARM template is hard. So about, or say, 18 or 20 months ago, Microsoft's product team, or the ARM product team, started a survey. Very luckily, I attended that survey. Eventually, this particular survey becomes the very original product requirement for Project Bicep. So Microsoft contacted all the partners, developers, and all the community users looking for the feedback of ARM template adoption, because they also realize that everybody is complaining ARM is too hard, ARM is too complicated, too difficult, and also not efficient in a real production environment. Then they started that survey, collected everybody's feedback. So at that point, there's a very strong competitor called Terraform, which use the HashiCorp code language, so we call it HCL language, to make everything very simple. So that language, so it's basically the YAML kind of semi-YAML based language, or it has its own syntax. So everybody, I believe, in that survey saying Microsoft, please develop a new language or at least a syntax that's very close to the Terraform. And now we can see Azure Bicep has very, very close to, especially the syntax is very, very close to Terraform. Sometimes makes me believe that Microsoft is start to copying or start to acquire Terraform in the future, then they don't need to do any other language development, then people will naturally transform or adopt Terraform, but unfortunately they didn't. They just developed it called Project Bicep. So this is Project Bicep. What's the relationship between Project Bicep and the Azure Resource Manager? Actually, the Project Bicep, or usually we call it Azure Bicep, is a simple decorative language to provisioning infrastructure in Azure. It's not replacing ARM templates. Actually, we can see with Azure Bicep, that Bicep language, the ARM template or ARM becomes the runtime of Bicep. So I would say with Bicep and ARM, the Microsoft native infrastructure as code platform become complete. So the ARM, basically the prototype, is a raw endpoint at the very beginning. Now we have a high-level language sitting on top of it, which makes this entire platform more complete. And I'll show you guys in the demo very shortly. In the Bicep, you are not bypass ARM. So underneath Bicep, once you start to provisioning, the system still translate or compile, or build your Bicep artifacts into a appropriate ARM template and deploy it. Vice versa, if you have a huge ARM template repository, you can decompile your ARM template or rebuild or basically reverse engineering your ARM templates into a Bicep artifact straight away, which makes you easier to transfer your entire workflow from ARM to Bicep. But underneath everything, still ARM is the very original root. Okay, so this is basically where the Bicep comes from and where we use the Bicep and when to use the Bicep, and basically the overview of Azure Bicep. Now the current version of Azure Bicep we will see very soon because it's still in the preview, but the major version has been upgraded from 0.2 to 0.3, now it's 0.4. Microsoft announced to the public preview at 0.3, which is already robust enough to do some small scale of production deployment. Okay. So let's now go back to demo. How could we start using Bicep? Azure Bicep is a native integration with Azure CLI, AZ CLI. So once you install the latest version of Azure CLI, you will get the Azure Bicep natively. So the command line you will still call it is called AZ Bicep. So the first thing when you install the Azure Bicep, what you need to do is to do an upgrade. Let's see what's the latest version of it. Okay. So I think the current version should be 04, and the minor version is 451. So I've already updated to the latest. Okay, so this is basically how we start deploying the Bicep artifacts using the AZ command line. We're using build, decompile. We don't need to actually install anything. List the version, upgrade, and version. So very, very straightforward. What we need to do most of the time is AZ Bicep build and follow with the Bicep file. So this is basically the very starting point of everything. How could we, once we have all the AZ Bicep command line installed in either your PowerShell core or whatever Bicep, if you're on the Mac, we can start to write Azure Bicep artifacts in using Visual Studio Code. What we need to do before we start to writing the code, one of the plugins we need to install is we call it the Bicep. It's currently in public preview, and this is the Bicep VS Code extension. Give you all the IntelliSense. I will show you how powerful the IntelliSense it is, as well as the language server and everything in Visual Studio Code. So we can start from a very generic file and select the language as Bicep. You can see the language has language server automatically being switched into the Bicep and load the Bicep language server. What we need to do, very, very easy. We've got a super smart IntelliSense work with us from Microsoft. And the syntax of Bicep is very, very close to Terraform. What we need to do is define the keywords, the resource, and give I would say, this is the symbolic name, which only be used as a reference name within this artifact. So I'll start with a simple storage account here now, and we can see storage account. So all of the Microsoft supported or the ARM supported or Bicep supported resource provider will automatically be populated in this IntelliSense, and as well as API version. Very, very smart and handy. Then now we start to use the bracket easily. So one of the nice thing is we'll start the name. I'll say AZ Bicep STG, AZ Bicep demo and STG. Cool. So next item, you don't need to deal with the comma. You don't need to deal with any brackets. And what is very important thing for this is the SKU, right? is the SKU, what I will say, yeah, it should, okay, sorry. And okay, sorry. And the location, and for here you can see the intelligent sense tells you the specific. You can see a error under the SDG. So that says the specific resource declaration is missing the following required properties, kind and SKU, which the Microsoft VS Code intelligence automatically pick up the mandatory field that you will need to put in for a specific resource, which is very, very smart. And with this, our intelligence reminder or co-pilot capability, you won't have any trouble of starting compiling all of these codes. So very, very easy. And let's start the code. I'll say SKU should automatically populate something. So what's the kind, blob storage, and also the SKU. The SKU, which is a bracket, and what we need in the SKU, we're missing a name. Okay, here the intelligence also, once you start to define the SKU, you don't need to know what SKU you actually need to define and find out anything from a API reference code, but IntelliSense will literally tell you which SKU is available. So any new SKU be added into the original REST API, you will able to pick up, or the IntelliSense will able to automatically pick up all of these things for you directly. Okay, will need to be a kind. Okay, usually storage really too. Okay, that's pretty much everything for this particular our very first Azure Bicep artifact. Now what we need to do, we can see we have a demo2 Bicep file. We just call Azure Bicep file, or you can say Azure Bicep build, give it file, and demo2 Bicep. What it will do, it will compile your Bicep file and make it to a JSON file, which is the very original, which is the ARM template-based JSON. See how light the Azure Bicep can be used to represent or decorate, like declare a certain resource that only have like less than 7 lines of code, but once it's been compiled to the ARM template, it will probably has like a 20 lines needs to be done, and all of these bracket format thing makes it really, really difficult to deal with. So this is basically the one of the beauty of the Azure Bicep that we definitely looking forward to everyone to start using that Bicep. Okay. And the second thing, we use Azure Bicep build. Once we complete the build phase. So definitely you can use Azure deployment group to create. You can use this command line directly in your Azure CLI to call a Bicep as an input for this. What the AD command line is gonna do is call the build first, compile it into a ARM template and deploy, and delete the ARM template as a interim storage. So you won't get that ARM template anywhere if you directly call Azure deployment group to create a Bicep input. But if you use Azure Bicep build, which is a compile procedure, you will get the intermediate ARM template being stored in a persistent storage. So this is I would say, from the left to right workflow. How could we do the reverse way? This is very tricky thing. I'll share one. So in my demo subscriptions, I have one resource group, which is called the demo resource group. And in this particular resource group, I have one Cosmos DB resource be created. So let's see, how could we reverse engineering this one? So in this particular demo, you will also get an idea of if you are not using infrastructure as code at all previously in the past, but now you want to start using infrastructure as code, how could you start building your initial repository, initial artifact? This is a very good starting point. Okay, let me log into my Azure subscription first quickly. Okay, so slow. Hopefully the Azure Active Directory doesn't have an outage anywhere. Right, you can use this command line, and alternatively, if you have the access to the Azure Pornographic UI, and you can also do this to export your template by clicking this button and then download a deployable ARM template in a JSON format. So that will be okay. Here we go. I think it's done. Okay, click. That's slow. Yeah, as you said, as I said, you can do this. And on the other hand, if you have any uh, any existing JSON file. Any existing JSON file like this, you can directly use the decompile method to decompile this. Okay, here we go. And let's do AZ group group export. What's the name of that? Name. Okay, what is my demo's name? Okay, here we go. And redirect type into, I'll say, export.json. Okay, it will take 2 seconds to complete the export, and sometimes it will raise error because some of the resources are not exportable. Okay, so that's fine. That doesn't matter. So now here, what we can see, I just get one. Where's my export? Oh, sorry. Okay. No. So this export as JSON, got all the MongoDB, which is Cosmos DB file created, as well as all the configurations, all the parameters, locations, everything in this particular JSON file. What I need to do, here's the dir, about the export. Okay, with AD, Bicep, decompile, go to the file, boom. Literally take just less than 10 seconds. It will generate the ARM template for you, but it still has some, I would say, unconvertible, or if there are some parameters need to be, if you use a function in the ARM template, or if you use a external reference in ARM template, it's still not able to be generated successfully or ideally, but it will straight away give you an awesome starting point. You can see even the parameter and manage to decompile it, everything, the parameter, all the resources, all the configurations, all the names has been successfully decompiled into a Bicep file. So this is still a starting point. Doesn't mean you can use it straight away, but it's decent enough for you to start development or debugging, or even start to initially deploying some basic resources in your environment. So one of another trick here is Microsoft got ARM startup GitHub. This is basically the Microsoft official ARM template repository for quick starts. It consists of like hundreds, thousands of the templates that you can start to use. And all of these resources, all of these templates has been tested officially that support the decompile of Bicep. So that is why when you jump into the Bicep project repository, Microsoft doesn't provide you any of the sample code here. Why is that? Because all of these existing ARM templates in the Microsoft Quick Start templates that support the decompile from the original repository. So there's no point to reinvent the wheel as long as you know the repository, the ARM template is there, and you can decompile it as your starting point. Good. So any questions so far for the online attendees? So please just raise your questions in the chat. So I will be watching the chat and answer the questions after that. Okay. Right. Let's switch over to another one. So this is basically we say from the right to left workflows. How do you build up your Bicep repository as quick as possible? There are also, I would say, the Bicep is more intelligent, more smart than the original ARM template is another thing. Even it got even more deeper, I would say, uh, IntelliSense. Previously, if you have a multi-stage, I would say the multi-stage pipeline that needs to get input from the previous step in your pipeline and pass the parameters or for example, you're provisioning a storage account that you need to pass the storage account endpoint to the next step. What you need to do is create the output section in the ARM template and use a object reference to absolutely pointing back to your original storage account that you provisioned. And also you need to manually type all of these in and make sure it's correct. It's very time consuming and you can easy to get something wrong. But here, let's have a look of how Bicep that can help us to simplify this output session. So when we start using the output, so first of all, still we need to give a, I would say, symbolic name. What's stg output? And you can see here, as every output, there must be a type associated. If, for example, I want to output the storage account endpoint, definitely is an object equals. When we type stg, it automatically show you this is an resource. And boom, the IntelliSense automatically populates using that symbolic name to populate all of the properties that you will need and that is applicable to the storage account. And you can even select much more properties from here automatically. You even don't need to type any words. So this is primary endpoint. So just by doing that, we automatically create using the object reference syntax to create an output in our Azure Bicep. So if we save this and az build, az bicep build, and give a file and see how difficult. Okay. If we have a JSON output here, originally your output will be looks like that, and there is no any IntelliSense or language reference or Copilot capability before we having the ARM template language server. But the Bicep is originally helping us to achieve that. Okay. All right. That's one thing of the Bicep. And there's another great feature in the Azure Bicep, which is automatically determine which resource needs to be provisioning first. So previously, in the JSON format or in the ARM template, if you reference a object or reference another resources from somewhere else, or even in the same template, you got a sequence saying that resource needs to, for example, you will always define depend on something something. This dependency won't automatically be picked it up. What does that mean? So the Azure ARM template will still simultaneously provision all of these resources and hit an error saying, the dependency doesn't work because you need these resources previous to be provisioned successfully, and then we can provision the next one. But in the Bicep, if you define a dependency, for example, the location or the resource, the next resource, I would say if we were having a resource called web, so if we define a Microsoft Web, mm, mm, if we uh, define, for example, a virtual machine or it requires, for example, a storage account to be provisioned first. So when the Bicep start to provision the resource, it will automatically pick up these dependency relationships and provisioning the prerequisite resources first, and then sequentially provisioning the next resource that depend on your previous resource, which makes the provisioning sequence and provisioning, I would say, the task sequencing stuff much easier. So you don't need to worry about anything of that. And the last thing I would mention in the syntax level is Bicep does support comment with our traditional comment format like slash slash, for example, any comment, then you can put. One thing I have to mention, um, the ARM does support comment, but it got a condition. So if you want to comment your ARM template in the JSON format, you can only deploy this particular ARM template using PowerShell commandlet. So using the Azure portal or your pipeline, it won't work because the Azure PowerShell commandlet will automatically process these comments behind things. So it does extra work to clean up all these comments before putting to a pipeline to deploy it. Because if there is some comment in the JSON originally, it doesn't support any comment, which makes the JSON format invalid. So using the Azure portal or REST API directly calling the JSON, directly calling the API using a JSON payload to provision the Azure resources, you cannot put comment anywhere in your JSON template. But Bicep has no problem with that. It supports seamlessly. You can comment anywhere as you want. How much of a beta is uh, so how much of a I just received a question from the chat window, which is asked by Mike, is about how much of a beta is Bicep? Hmm. I don't know, but the current
but basically it's free, so everyone can use it. It's open source platform. The current version is this, but Microsoft, I would say, make it now zero point 0.4 is still a production grade. You can start using that anyway. I don't know how much they're going to beta it. It's really dependent on the product maturity. Um, I would say very soon, so everyone will start to. Microsoft is definitely pushing to use the Bicep as much as possible in the very near future. And basically, Microsoft won't stop maintaining ARM because that's basically their root. But other than that, at efficiency or utilization level, definitely Microsoft will push everyone start to shifting to Azure Bicep as soon as possible. Okay, that's pretty much about everything regarding the basic syntax. There are some advanced techniques, like especially around the module, which usually, while we're using the Azure ARM template, modularize your artifact is not that easy. But for the Bicep, you can straight away use any module. See, you can automatically link it to then the module will automatically read the target Bicep and also this parameter and all of these resource types. So which means makes you have a individual resource to be created as module, and you can have a masked Bicep to basically put everything all together. So this is basically makes the traditional, or we call it nested ARM template method much easier instead of using the nested ARM template. So next, what we're going to quickly look at is how do we integrate your Bicep into your your CI/CD workflows. So what we need to do here basically is create a YAML-based um, pipeline definition file. We can say here what the name is deploy Bicep files. We don't need any variables. Maybe vi variables. Say image name. Usually we'll use Ubuntu latest. Then I'll leave all the rest things here to show you. But a simple pool, VM image, VM image name. Okay. Then the next very important thing is the steps in the pipeline. We'll have a task. Azure, usually we use the CLI to deploy, and its input is Azure, okay, Azure subscription, and give it a, I'll say, usually sub ID, and also we do script type, use the bash, and script location, it's inline script. Okay, so the next is the very important, so we'll do inline script. What we do is using HC deployment group create. What do we need to create is basically the actual resource group. For example, a demo resource group, and also give a template file, which you can use your, for example, demo 1 or demo 2 Bicep file. So basically, the idea is to using the inline script in the bash to using the deployment group create. Basically, here using the Azure deployment group create to create a deployment, as well as basically without calling the Bicep build. And once you basically upload this YAML file to your Azure pipeline, that pipeline will automatically pick up all of these definitions, create a Ubuntu deployment virtual machines, and then load all your artifacts. Then the artifacts definitely contains all the Bicep. For example, if you use a nested, you can use a master Bicep file to puppet all the underneath sub Bicep file deployment. So this is very, very simple. And also, if you use a graphic based Azure DevOps pipeline, you can basically just create a task called inline script deployment and put this particular commandlet into the inline script. So pretty much basically using all of these things, we can start to have a end-to-end workflow from compiling or writing the Azure Bicep file, doing the reverse engineering to quickly build up your repository, and as well as integrated everything into your Azure DevOps working pipeline. I believe in the future, there are some other things Azure Bicep will be introduced has been introduced very recently, is to enable the Azure Bicep deployment to be able to cross different scopes. So very originally, if you want to create a resource group or management group, which is above the subscription or resource group level, you need to use a separate ARM template to deploy management groups. And once you deploy that, the next step, you can do something underneath that, like the resources or resource groups to provisioning something under the management group, which is ARM template use different or we'll call it scope. But within the Bicep, you can do the scope switch on the fly by just putting a, what we call scope keyword in there. So you can create a scope or resource group or something like that. So this is something very, very newly be introduced, which means you can put all your infrastructure as code from the top of your management group to the subscription, to the resource group, and to the resource and sub-resource level in one single Bicep file without doing all this scope switch. So this is something very, very new being introduced in the Azure Bicep. I think that will make everything much easier to handle, especially around the masked Bicep file. The scope will be managed at the top level, and you don't need to separate. And also, parameter file can be managed in a single parameter file easily. So this is pretty much makes a Bicep completely usable to replace traditional ARM template-based deployment. That's all for today's content. I want to say in this particular Bicep topic. In the next, I would say, session, probably looking at to covering some very hitting topic, which is basically just be introduced in the Inspire this year, 2021, which is the Microsoft Azure Virtual Desktop Cloud. This is something I would say everybody start to looking at, and also touch some of the industry cloud as well. Hopefully we are right. We are right on the time. Hopefully everyone enjoy this session. I will be sorry, we can't deploy. So just one question. We can't deploy currently at tenant level. I would say the management group is the highest level we can deploy. So I think the management group is basically the tenant level. At a tenant level, if you have to say, you can deploy one thing, which is the role assignment. And also, I would say there's another one I just come across very recently. It's called something tenant configurations, which is you can enforce some tenant level properties, like for example, some security, especially security things around your tenant. So yes, definitely, if you have to say yes at tenant level, management group level, resource group level, and resource level, you can deploy at all these levels, particularly around the role assignment is, I would say, the tenant level. Hope that answer your questions. Yeah, AAD tenant level, yes, you can. No, so the Bicep is only for Azure, so not for AAD. So you can't use the Bicep to configure Azure AD, but at Azure AD level, what you can define is the RBAC role assignment particularly. So hope that answers your question. Okay, so yeah, cool. So that's pretty much everything for today. I will stop streaming. Everyone can come back and watch the replay, I think, after a day. Then I will continue to stay in the chat room for a while. So, yep, thanks everyone for coming. See you next session.